Hello students, welcome to the channel The Royal Chemistry, all about the chemistry. Today's session we are going to discuss about calcination. It's a process of conversion of an concentrated ore into the metal oxide. In my previous video I discussed about roasting. These two methods are needed for the conversion of concentrated ore to the metal oxide. Let's see completely about this calcination. First, calcination. What is calcination? The IUPAC defines that the calcination is an heating to high temperature in air or oxygen. So we are going to heat the concentrated ore to a high temperature for converting that concentrated ore into an metal oxide. So in this calcination process also used to mean a thermal treatment process in the absence of limited supply of the air or oxygen below its melting point. What's the importance of this calcination is, it is considered as the process of purification, or else you can say it as heat treating. So a very good example for the conversion of the ore into metal oxide here is manufacture of lime from the limestone. Let us see the principle behind this calcination process. A process is carried out here with a high temperature, that ore should be heated to a high temperature below its melting point, noted down, in the absence of air or in a limited supply of air. A well example for this, for the conversion of concentrated ore into a metal oxide, is zinc carbonate decomposes to give zinc oxide plus carbon dioxide. So this process can also be carried out even with a limited supply of air also. So how come we will do this calcination process? What are the examples of that? What are the ores will undergo this calcination process? The very first one is calcination of the carbonated ores. It is more fairly applicable to the carbonated ores. Here you are seeing about kerosite and calcium carbonate convert itself into, on heating itself into lead oxide and calcium oxide with the liberation of carbon dioxide. Okay, so next example is, that's what I told you, that zinc carbonate, calamine, on heating high temperature calcination gives zinc oxide per carbon dioxide is released out, like that dolomite. Now calcination process is of hydrated ore we will discuss. During that calcination of the hydrated ore, water of hydration is expelled out as vapor. Water of hydration is expelled as vapor. Here the example what we have is iron oxide with the presence of water and alumina in the presence of water. On heating, both of that equation gives its oxide ore. Why we are converting that concentrated ore into an oxide ore? Because the reduction of, the next step is reduction, that is melting. In that case we are going to convert a metal oxide into a metal. That reduction of oxide is easier when compared to the reduction of the other compounds of the metal. That's why we are converting that ore into a metal oxide. Okay, here the ores are, why we are heating this in the absence of air? Due to the conversion of metal carbonates into metal oxide and carbon dioxide. Let's see about the furnace which are used for this calcination process. There are three general classes. One is reverberatory furnace. The second one what we are using here is shaft furnace, or you can say it as kiln. The third one what we can use here is muffle furnace. So furnace is used for the reaction to carry out. Next one, why calcination is done in the absence of air? I told you that metal carbonates are converted into metal oxide and carbon dioxide. These are the apparatus, that is furnace used for the calcination process. One, reverberatory furnace, second one, shaft furnace, and the third one what I given here is muffle furnaces. Okay, so calcination means heating the concentrated ore to high temperature below its melting point in the absence of air. Okay, let's see. Calcinations are only applicable to the carbonate and the hydrated ores, and it is not applicable for all other ores. Why? Because the ores cannot be reduced because it is energetically not favorable. That's why we are not using calcination process for the other ores. I hope you will understand this concept of calcination in this video. My next video is about the flux and the slag. Let's see in that video. Thank you for watching.